Hi friends, welcome back. So this is the remaining piece of the puzzle. So how we took the actual data from movie lens and how did we really prepare it to make sure that it is compatible with what we want to do from a search perspective, right? So like I explained before, we took the data from Kaggle website, and it's in a weird format. It's got some CSVs and then individual CSV columns or JSON objects, etc. And it needs a special schema to read, etc. And then if you look at my other videos, that'll go way in more depth to understand what ETL we did and how we took the data and shredded it all the way to take it into a complete relational normalized format, right? Obviously, with the search engine. The complete normalized process is not going to work well. So with that approach, right? So we need to kind of denormalize it a little bit and then create uh, a document-based model where each movie is self-contained with all the fields that it needs. Some of them are going to be one-to-one fields, and then some of them are going to be really one-to-many fields, right? So this ETL is using Spark for doing that. It's going to take the data from the normalized outputs that we generated from the previous projects, and then it's going to actually join them back together on the keys, and then create an inline document with a one-to-many array kind of a relationship. So that is this code. Should be straightforward if you kind of understand Spark. If not, I'll just kind of give you a walkthrough here, right? So what we are asking here to do is we're going to send the we're gonna write the outputs true, and then if you want to test it out and don't want to write outputs, that's fine, you can say false. So what's happening here is it's asking for the folder where all the shredded movie lens data is. So if you kind of go back and understand the structure, I think if you go back to the old videos, you'll be able to see it. But for a quick recap here, right? So if you go back here, if you go to this root of the project, there's actually WWIO2. And then in here, this is all checked into source code. So if you go to open to movie lens, here's where all the individual data elements that are normalized are sitting. So movies will have movies data in Parquet format. Movie genre is a connection between movies and genres, right? Genre is its own table, movies is its own table, and the genre relationship between one to many happens here. So one movie can fall into many genres, and there can be many movies of the same genre. So this is a kind of a link table in a relational world of things, right? So what we are trying to do here is reading each of these parquets and then doing a join, asking Spark to do the join. So coming back to that, right? Straightforward. We pick for the directory. We ask for the directory. And then we set up the error logging to be log level empty error to reduce the amount of chatter. Then we open the movies data frame. So it's nothing plus nothing but this arguments slash movies that will have a bunch of Parquet files, which are the actual movies. Then the same idea, we take the genre and load it to movie genre, and then genre also we load into genre. So there are three data frames or data sets, if you want to call it that way. And all we are doing now is doing the reverse of the shredding process. Now we're actually going to join it back. So movie genre will be join movie genre to genre, and then you get the and you drop the genre ID. So that way, you keep one version of the genre ID. Otherwise, it will keep two columns with the same exact name. So movie genre, that's the link between those two, and then movie genre one is nothing but joining the um, getting the aggregations, right? So when you do a join, you will have one to many relationship and multiple rows. And now what we are doing here is actually doing a collect set operation. So when you do a collect set on Spark, what it does is for every key that is a movie ID in this case, it will actually generate a collected set of all the genres that it falls in, right? And same thing, what we are doing is in this movie genre 2, we say if any movie ID is not null, remove it and then rename the columns. Should not happen, right? There should be no case where movie ID is null, but we apply that filter and then we rename the movie ID to movie ID 1 so that we can connect it to the other data set, right? So same thing, we take the movies data frame now, and then we connect it to the movie genre 2 that contains a collected set of genres by movie ID, and then we join on movie ID. So at the end of all this, basically what you have is one movie with a collection of individual genres. So we do the same exact thing for two other things, right? Keywords. We get all the keywords, we join the keywords, collect the set, and then join back. Same way we do for the cast. So we take the cast, we movie cast, we take the cast, join that, collect the cast as cast name, say this cast, and then we join back. So the end of all these processes, what you will have is one file, like a data set with the one-to-one columns remaining as is, but all the one-to-many columns now will have a collected set. So it will be like a array representation of it, right? And then what we do now is we write that directly back into the JSON format. You repartition to one, write into JSON format, and then we say it's a cog search file. So don't want to run this again, but I can show you what the output will look like. So this is the output file, and you can see it's a JSON document. If you open that up, you will see this one. So what we can do for quick understanding is, this is what we have pushed to the index. So we can query the index and kind of see the structure in a more formatted way. So that's kind of what we will do here. Like go to the search explorer here. So every row that I showed there is basically this one, right? So every row there here is this one. And so it'll have the movie ID, is adult, budget, etc. All these are one-to-one fields, so straightforward. There's nothing special. But once you come to the three last things, right? Genres, it'll actually be a set of elements. So in this case, you have genre as one set, keywords has got all of these, cast has got Lena Dima, right? So if you go to another document, this is genre is documentary, and then there's no cast in this particular document. Then you go to Jaws, then you can see it's in three different genres: thriller, adventure, and horror. And then you can see all this, which makes sense, right? Jaws is all about this ferry boat, bathing, police chief, animal horror, whatever, right? So you get all the keywords, and then there's no cast. Maybe it's the data quality issue too, but it's okay. It works, right? So this is like basically it has all of this. So you'll have the different elements. So this is kind of what the document ETL is doing. It's taking all that data, merging it back, and making it easier for us to handle, right? And then each of these columns that we have specified, that we actually when we configure the index structure, like what data is there in the index, we actually allow it to be searchable, um, etc., right? So if you come back here, go to the indexes, and then open this Babylon's index, and then if you edit the JSON here, you can see, if you scroll down all the way, you will be able to see what are the actual, so like this one, right? Name is genre. If you see genre, something but a collection of strings, and it is searchable, it's filterable, it's retrievable, it's sortable, and it's facetable, right? It's not a key. And then you can do all these other normalizations and synonym maps and whatnot. We're not doing any of that, right? So it's good enough for this use case. And that is kind of what it is, searching on and then giving us answers. So hopefully that is clear. That is it's an easy piece of the puzzle. It's just the indexing, right? So that is the core piece. So we took all the data that we had prior, normalized format, denormalized it, collected it as a set using Spark, and wrote it down as a JSON object. And that JSON object that we got here is what we are posting to the Azure Cognitive Search Index, and that's where it gets indexed, and then it allows us to search and facet on different things. So hopefully this helps to get the picture of the end-to-end flow. So first we have the data, then we have the ETL, then we have the JSON searchable documents, and then that document is getting pushed into the Azure service, where we create an index, and then we have the Java code that can interact with the Azure Cognitive Search as a library, and then you have the bot actually in the front end, right? That's actually Spring Boot application, and then the actual Azure bot which talks to this backend to produce the output. So hopefully this was a good explanation, and gave you a good picture of what you can do. So hopefully you liked it and learned something from it. Thank you.